Today, we're going to be going over the AWS Reinforce presentation on securing serverless and container services. So throughout this presentation, we will talk about how serverless and container services are built. We're going to go over a model that we can use to build security into our serverless and container services. We're going to talk about how we can embed all of these strategies into a pattern of security deployment. And we're also going to go over a demo to see how we can make all these things work together. Okay, so let's get into serverless and container services. When talking about serverless services, AWS aims for the removal of the heavy lifting of everything that is related to server operations to make it as simple as possible for their customers. Things such as management, patching, maintaining and providing infrastructure are what they aim to take away from customer responsibility. AWS also aims to provide automated scaling and a pay-as-you-go model. Additionally, AWS looks to build these services in a way that is highly available and secure. Serverless in AWS is an operational model that spans across a lot of services. Under compute, they provide services such as Lambda and AWS Fargate. For data storage, they have both object and database storage, supported by services like Amazon S3 and Amazon DynamoDB. AWS also aims to provide a number of services to manage the integration of all these services, such as API Gateway and AWS AppSync. The purpose of serverless is to make things easier. Here we have an example of API Gateway being implemented to be able to receive and handle requests from external services. We can write code to leverage Lambda functions to manage and deal with those requests and to also apply business logic that is defined into the code. And we can use DynamoDB to store our data to make our business logic work. From a security perspective, we have to build authentication and authorization into our API gateway and build proper input validation and IAM permissions into our Lambda functions. We also have to make sure that our data is available through backups. Because we are able to follow a simple pattern, when it comes time to scale up, the pattern we use can also be repeatable, and that facilitates the controls we are able to apply because the type of controls remain consistent. While the form and content of said controls can vary, the pattern remains consistent and repeatable. When it comes to the coexistence between serverless and non-serverless environments, things get a bit more complicated. Because infrastructure exists within the non-serverless environment, in many cases, this infrastructure is built in a traditional model of perimeter security, which means that some of the infrastructure is still needed to manage our business logic. This ultimately makes our repeatable pattern of security controls much more difficult to implement because we have to make both the serverless and non-serverless environments coexist. The core business logic is naturally the most important element alongside the data we are protecting. AWS has realized that both serverless and non-serverless environments can follow a similar model, which doesn't change much when the core business elements use either code or containers. Both technologies have been developed in a common pattern with the goal to support microservices. As we already mentioned, the core business logic can be modeled as code or containers because regardless of what we use, we still have to protect them in the same manner. AWS has created a model that supports both serverless and container architectures, which we will go into more detail in the following slides. Now we can go into more detail in regards to the model that AWS has created to define the security controls that need to be put into place. Now let's take a deeper dive at the different layers of the architecture. The compute layer handles core business logic in the sense that whatever combination of services you decide to use are in charge of handling requests for internal and external systems. Additionally, they also have to process those requests and ensure that those requests are handled properly. The data layer is where the state application data is handled. And like compute, there are services that target customers aiming to use both infrastructure and no infrastructure. The communication layer is what ties all the services together by providing links between our core services. The edge is what AWS determines as a way to connect their services to the rest of the world. Access management and identity provides the permissions for both internal and external users and additional utilizations. The system monitoring and deployment layer provides visibility and traceability into how our services are performing. The security perspective around the cloud adoption framework helps you structure the selection and implementation of controls to make it easier to identify areas of non-compliance and to plan ongoing security initiatives. AWS has determined that there should be 4 types of controls around any service. First, directive and preventive controls serve as a way to ensure that the initial state of the provisioning of our resources is as desired, whereas the detective and responsive controls are implemented to look at what's going on with our services and to react to any changes when needed. Now let's go back and take a look at a few key services under the compute layer. AWS Lambda is a serverless service that runs your code in response to events and automatically manages the underlying compute resources so that developers only have to worry about writing the code and choosing when they want to run the code. AWS Fargate is a service that allows you to run Docker containers without managing any servers for orchestration. Although Fargate is similar to Lambda, it provides a lot more flexibility by allowing you to have full access to the configuration of your containers. ECS manages containers and allows developers to run applications in the cloud without having to configure an environment for the code to run in. EKS is a managed Kubernetes service that makes it easier for you to run Kubernetes on AWS and on-premises. This is a representation of the level of operational responsibility needed by the customer when using these services. This starts off with Lambda, and it requires the least, as you are only responsible for managing code and the runtime of that code, and ranges all the way to Amazon EC2, which requires the highest level of responsibility from the customer. Now let's take a deeper look at security in the compute layer. AWS has observed that customers face 3 main issues when it comes to securing the compute layer. These 3 issues consist of input validation, dependency vulnerabilities, and storing secrets. Here we have examples of the many services that AWS provides that can be used to mitigate each corresponding issue. Lambda Layers provides a way to use code across different applications. Developers are able to create a number of Lambda layers that are able to be used and reused by other Lambda functions. The Lambda execution environment provides a runtime interface for getting invocation events and sending responses. You can deploy custom runtime alongside your functions code or in a different layer. Currently, there are 2 models for runtime environments. We have the traditional model for EC2 instances where we dedicate 1 micro VM to build serverless execution environments in 1 single EC2 instance, whereas the Firecracker model shares the hardware between accounts. Below are a few considerations a developer might want to consider when writing out a Lambda function. Below is a list of recommended best practices when using Lambda. Unlike AWS Lambda, customers are responsible for the management of the networking, identity and access management, and hosting services of Amazon ECS and Fargate. Below is a representation of the key differences between these 2 services. When it comes to the security in the data layer, AWS has outlined key concepts such as data classifications and data encryption, along with key services that can be used to support these. When it comes to the access management and identity layer, a couple of key takeaways are to authenticate and authorize end users through either API Gateway or Amazon Cognito. Additionally, we can manage the control between services through AWS IAM. When it comes to securing in the system monitoring layer, we are looking into the visibility and tracing of our services. We are able to use AWS services to log our environment, track key metrics, and maintain compliance validation. AWS X-Ray is a service specifically designed for serverless and containers. It allows us to get a deeper view into what's going on with the data flows and treatment of code. X-Ray provides an end-to-end view and allows us to detect choke points in our applications. X-Ray can be easily integrated into our Lambda functions with a simple check of a box. X-Ray integration with containers works different than with serverless in the sense that an X-Ray Docker container needs to be deployed. When looking at security in the deployment layer, we must consider how we want to manage version controls and code quality. AWS provides services that can be used to help improve security throughout the whole deployment cycle.